This is APAB. We're doing Intro to BC, and this is parts. So in example 4 of parts, I'm going to give you a pretty common trick question. This is parts with two functions that loop. So neither of these ever derive to 0, and what's weird about them is because they both loop, eventually you're going to end up with the same integrand that you started with, and you're going to have to sort of treat it like an algebraic quantity unto itself and then move it around like a like term to solve. So you never actually kind of finish integrating. It's sort of weird. So let's walk through this. So I know by Liat, right? So I know by Liat that although both of these guys are very much at the end of Liat, the trig function should be my u. So I know that my u is cosine and that these guys, my e to the x dx, must be my dv, right? So I'm going to inch over here for round 1 of parts. And I am going to emphasize that it's round 1 because this is not a short problem. So round 1 of parts, my u is cosine of x, my dv is e to the x dx, my du, when I derive cosine, I get negative sine of x dx, and my v is just an e to the x, right? So I do uv minus v du. So that's going to mean that what I get is uv, so e to the x cosine x, if I write it in the order I'd prefer. And then when I subtract minus v du, I'm going to end up getting a positive because there's already a negative here. So I'm going to make this plus the integral of e to the x sine x, which is going to require another round of parts, right? So this is going to require round 2, right? But this is going to keep being a problem. It's not just a problem now. It's going to keep being a problem because they're going to keep looping, right? Eventually, e to the x is going to keep being e to the x, and sines and cosines just loop around every 4 terms. So let's see what happens. So we're going to go ahead and inch over here, right? And we're going to get ready for round 2, okay? So in round 2, I have this e to the x cosine of x plus, and then I'm going to do round 2 of parts with this e to the x sine x dx. So my u is definitely the trig function, that's my sine x. My dv is the e to the x dx. My du is a cosine of x dx. And my v is an e to the x. So now I'm going to do my uv minus v du, minus the integral of v du. And I'm going to get e to the x cosine of x plus uv, which would be e to the x sine x, right, minus the integral of e to the x cosine of x dx. Now, I'm going to stop right here for a minute. I'm not done, right, yet, but I'm darn close. So now what I'm going to do is I'm going to take this answer, and I need to give myself some space so you can see what I'm about to do. So I'm going to take this answer, right, and I'm going to erase all of this work that I just did, and I'm going to copy that answer back up here and set it next to that integral. So if I copy this answer back up here, right, I get e to the x cosine of x plus e to the x sine of x minus the exact integral I started with, right? So think back to like algebra 1 skills, right? If we called this a and said this equals this thing plus this thing minus a, I could move that stuff to the other side. So that's exactly what I'm going to do. I'm going to move this integral over and end up with 2 of them, right? If I move this integral over, I end up with a 2 times the integral of e to the x cosine of x dx equals e to the x plus, cosine of x plus e to the x sine of x, right? And I'm going to go ahead and put plus c because I'm done integrating on this side, right? There's no more integrating. And then I'm just going to divide the entire thing by 2. And my final answer is going to be e to the x cosine x plus e to the x sine x plus c all over 2. Now you could either put the c inside the division by 2, or you could put the c on the very end because c over 2 and c by itself are the same in this case, right? But I chose to put it on top of the fraction, okay?